All right, for geometry today, sorry, I gotta move that out a little bit. We're doing 3.5 equations of lines. So some algebra review with our geometry, which I'm sure is exciting for many of you. In a minute, after we do notes, you can have the whole punch. Okay, so first up with this, we have standard form, okay, is our ax plus by equals c. You need to remember that neither a or b can equal 0, and a has to be greater than 0. So that just means we can't have fractions or decimals, right? A has to be a whole number. Okay, when we have this, okay, we can find the intercepts of our line. So we can, when x equals 0, when the line crosses the y-axis. So we're going to use x equals 0 to find the y-intercept. Totally backwards, right? We want the y-intercept, so x is 0. And when we want the x-intercept, we're going to use y equals 0. Okay, they're totally backwards, I know. The line postulate guarantees a line can be graphed using just 2 points that satisfy the equation. Okay, when we do slope-intercept, or sometimes we want to use 3 points. I always like to have the third if I can, but technically it can be done with 2, and that's what we're going to practice with these intercepts today. So, example 1, use the x and y intercepts to graph 2x minus 3y equals negative 6. So to do that, we're going to use those intercepts. We're going to plug x in for 0, or 0 in for x, pardon me. So 2 times 0 minus 3y equals 6, negative 6. And then the other one, we're going to plug, we're going to leave the 2x and have minus 3 times 0 equals negative 6. Okay. So far, does that make sense, though? We're just going to put 0 in for x here. And then on this one, we put 0 in for y.
Oh, I remember these.
Okay, good. And then we solve them, and we'll find our intercepts so we can graph. So this is going to leave us with negative 3y equals negative 6. What do I do? Divide by negative 3. So y equals negative 6 divided by negative 3. 2, positive 2. So my coordinate here, my ordered pair, my 0 was x, so it's going to be 0, 2 is what I would graph. So 0 and then up 2. That's, look at that, my y-intercept. Okay, so for then the other equation, I just have 2x equals negative 6. What do I do to solve, Lucas?
So you divide the 2x by the 6.
Nope, I wouldn't divide by the number that's being...
X, just the 2.
Okay, so I'm going to divide by 2. Good. So x equals, what's 6 divided by, negative 6, pardon me, divided by 2. So negative 3 is x. So my coordinate this time is negative 3, comma, 0. And so I graph that. Negative 3 and 0. I don't move up or down. And then I graph my line. But I use the intercepts to graph. Very nice. I feel like you guys are super quiet. You can just connect it with your freehand. You don't, unless we're doing constructions, you don't need a straight edge to make the line. Good call. All right, so then we're going to look at slope-intercept form, which is different than standard form. Slope-intercept form, I don't know why everything is so crooked, I feel like, on my paper. Okay. Okay. So slope-intercept form is that y equals mx plus b. So lines can be graph quickly using the slope, which is m, and the y-intercept, which is b. So we've got a few reminders here. M is for slope, stands for the change in y over the change in x. Do you know what I mean by the change? x2 minus x1, different things. Okay. And the b is our y-intercept, which is always going to be 0, comma, whatever b value we get. So example 2, we're going to do, write 3x plus 4y equals -4 in slope-intercept form. And then we're going to graph the equation using its slope and y-intercept. So we've got to get it in that form, which just means we're going to manipulate the equation, move things around. Okay, so we want the y, so what are we going to do? So we need to subtract 3x from both sides, right? When I'm talking about both sides, I'm talking about both sides of the equal sign. So 4y equals, we're going to go ahead and write the -3x first because we want that idea of the x value to come before our b. So -3x minus 4. And then what do I do to get y by itself? Okay, divide by 4. So then we're going to have y equals -3/4x minus, what's 4 divided by 4? 1. There's our slope-intercept form. So what's the slope here? The -3/4. Good. And what's the y-intercept? Not 1. -1, right? Because it's minus. We have to take that with it, so it's a -1. Okay. So we're ready to graph it. So our y-intercept is always, remember, 0, and then our b, so 0, -1.
And then you just go, I would do +3, -4.
Okay, so you would do +3. So to do that, we would get rise 3, 1, 2, 3, and run -4. So 1, 2, 3, 4. So we went up 3, and we went back the -4. We could also go down 3, 1, 2, 3, and rise and run +4. 1, 2, 3, 4. Right, but here we went down 3, so there's our -3, and we went a +4 running. So you can do either of those and then graph your line. Yes.
A lot of people would say this is giving them PTSD forever.
Good. Good.
And I love algebra.
Awesome. Any questions?
And now you're a good teacher. Once you go back to geometry, you're not. But
I see how it is. Any questions? We're good? All right. Then let's go to the back. We get to write an equation. All right. So write the equation of a line from a graph. We want it in slope-intercept form. So to do that, we're going to find the y-intercept on the graph. Okay. So in here, right, there's our y-intercept. It's where it crosses the y-axis. Okay, we use 2 points to find the slope. We have to have 2 points. Or, since it's, right, we have it. I showed it there. And then we can show our rise and our run for those. Okay, and then we can write our equation. So from this, what's our m? Hold on. What's our m?
our slope is
1/2, right? We rose 1 and we ran 2. Okay, and what's our y-intercept? What was that point? 3, right? 1, 2, 3, and it was given right here. So yeah, y-intercept is b. So I left on there. So Justice, what's the equation then? Nope, we say y. Nope, we want it because we want it to be y equals, so y equals mx plus b. And we will always, when we have it in this form, we will plug in the m, and we'll plug in a b, and we'll leave everything else. Ding, 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 and you're done. Right, we always plug in the slope and the y-intercept, and we leave the rest. Because You can now pick any point. Like if you're like, well, what's y when x is 2? You can plug it in the x in and you can solve for y. Like you'll always have y and x in your equation, no matter if it's standard form or slope-intercept. Okay, so what if you don't know the y-intercept, but you have a point and the slope? You can substitute the point's coordinates, so x and y, and the slope into the equation, y equals mx plus b, and you can solve for b. You can find it. So in example 3, it says write the equation of the line through point -5, 6 with a slope of -1/2. And I left y equals mx plus b there for you. Okay. So we're going to have 6 is our y. Good. So 6 equals -1/2 is our slope. -5 is our x. Plus b. No, plus b. Right. Okay. So plus b, because we just plug those numbers in directly. And so now we just have to solve for b. 6 equals 5/2 plus b. Okay. 5/2 might be easier if it was a decimal. We might be able to do that a little quicker.
Oh, it's 4.5.
No.
2.5.
2.5. Okay. So again, it doesn't matter. So it could be 6 equals 2.5 plus b. But some people really don't like fractions, and you can do either one. So what would you do next at this point? We can't divide because 2.5 is not being multiplied. We would subtract it because it's being added, right? 2.5 or 5. So we would minus 2.5. So what's 6 minus 2.5? So 3.5 equals b. Okay, but it says, oh, go ahead. Did you have a question?
With the fractions, could you just do like, would you like kind of like times it 12/2?
You guys are doing a lot more steps.
You don't. Well, I mean, you do, because you'd have to subtract 5 halves. Okay, but if you know it's halves, this would be 12, yes, over 2. 12/2 minus 5/2 is 7/2 equals b. Totally fine. Yep. Are we done? We solved for b?
Yeah.
Are we done? No. Okay, good. We're not, because we have to write the equation. So the equation of this line would be y equals, okay, good. So it would be y equals -1/2 x plus 3.5 or plus 7.2. Excellent. Beautifully done. I would agree. It's better than geometry, but okay. All right. How about the next one? Don't know the slope, but you have 2 points. Okay. We can use the slope formula. So m is that change in y over the change in x. Then we can substitute the points and solve for the slope. Then substitute 1 point and the slope into the slope-intercept form like we just did on example 3 and solve for b, and then write our equation. Okay, this one's a little bit of work because it's a word problem. So according to the U.S. Lacrosse Annual Participation Survey, the number of youth players increased from 300,000 in 2009 to 400,000 in 2013. Write a linear equation modeling the growth of the sport. Okay. Okay, so I took this, and we've got 2009 was 300,000 students. So we're just going to say from 2000, since both of these have a 2000 in them. So we're going to make the coordinates 9 and 300,000, and then 13 and 400,000. Does that make sense? Like they go together. That's their relationship. But instead of having 2009 and 2013, we can cut that part down a little bit. Okay. Okay. All right, so this says, first we need to find the slope. So m is going to equal 400,000 minus 300,000, good, over, because that's our y values. Nope, we're not going to use 2,000. Remember looking at these coordinates here. I wrote them out as coordinates for us. What was it? 13 minus 9. Okay. So 400,000 minus 300,000 is 100,000. And 13 minus 9 is 4. Okay, that took a little longer than maybe I would have thought. And what is that if I reduce it? 25,000 over 1. Okay, perfect. So that's our slope, is that 25,000. So, right, we use the slope formula, substitute the points. So we found slope. Now we need to substitute 1 point and the slope into the slope-intercept form. So we want to plug it into this form now. So 300,000 equals 25,000 is my slope times x. What's my x value? 9. Okay, plus b. Right, because we're solving for b.
Can you figure that? Oh wait, no, that's not right. It'd be equals 225,000.
Yes, I was doing 5. What on earth? It is 225,000, not 175,000. Yep. I'm assuming. Yes, it is. Okay, and then what do we do? Subtract that 225,000. So 75,000 equals b, okay? And then we put it into the thing, okay? So what's our equation going to be?
25,000 over 1x.
It's okay if you leave it. It's okay. Well, you can have it as 4x and stuff. You just have to know that it's 4 over 1 or 25,000 over 1. So yes, this is your equation. Granted, they were huge numbers, but they weren't terrible numbers to work with. But they're just big.
No, at least it's not like 300,000.
Right. Yeah. They're not random numbers. It's kind of easy. It's wonderful to hear. Some good review.
You're gonna make it hard.
No, I'm not making it hard today.
Today?
Yeah, it is actually a pretty easy section, chapter, whatever.
Let's keep all the chapters.
Because I think this is actually even the end of the chapter. Well, we'll have some review stuff first. Okay, so then parallel lines have equal slopes, which you know, we've talked about a lot. Perpendicular lines have opposite reciprocal slopes. So I've given you the example there. So if the slope is 3/4, the slope of the perpendicular line is going to be negative, that's the opposite, 4/3. That's the reciprocal part. Okay.
It's almost, these drawings are really, really good. It's almost like you saw them out of the book or something.
Well, I mean, I made my own, but yes, they were in the book. I just...
That's your drawing. That graph, that's your drawing. You just did good.
Thank you. All right. Okay, write the equation of each line passing through P. Okay, so we've got P on our graph. Let's go ahead. What is P? Right, let's name it with its coordinates. Does anybody agree with that? -3, -1? Yes? Okay, I got a confirmation. All right, so A, we want to write a line parallel to K. And so K is our line. Sorry. And perpendicular to K. but it has to pass through P is the deal. So we need to find the slope. You got it.
+1 or +2 +1.
Okay, so let's look at K and find K's slope. So if I pick a point here and this point right here, I rise how many? 2, and I run 1. So my slope is 2 over 1, or 2. All right, so let me write this here. So my slope of K equals 2 over 1. So what's the slope of my perpendicular line going to be?
2 over 1.
Why is it going to be 2 over 1?
You said parallel, right?
I did say parallel.
Because they have to have the same slope.
Parallel has the same slope. Perfect. Okay. Well, so now I have the slope, and I know I have to go through this point P. What do I do? Right, I know it has to go through point P, which is -3, -1, we
Wait,
said.
1 second. You said the perpendicular slope is the reciprocal, right?
Is the opposite reciprocal.
So and perpendicular, wouldn't that equal -1 over 2?
Yes, so if we were looking at M for the perpendicular line, it would equal -1 over 2. I drew that here, but it should have just been M for the parallel line. I'm sorry. Is that what you're talking about?
Yeah.
Good call. So M for our parallel line, which looks like M11, but. So if I have a slope and a point, how do I get the equation? -1 equals, I'm going to plug them into slope-intercept. Good.
2 -3 + b.
You got it. Okay, so she just plugged her x in for x in the slope-intercept form and y in, and then we solve. So -1 equals, so we add 6, and so 5 equals b. Good. And then I put it in the slope format. So y, Lucas put it in there. Y equals, we've got our slope, and now we have our b. Yes?
And then you put
Plus B.
Plus,
what's the b number for b?
so remember we have y equals m
Plus 5.
x plus b. So we plug in the 2 and we plug in the 5.
Do you really need to know the mk and whatever it is? Like, I know that's slope, but you have to, like,
As long as you have it somewhere, I just wrote that the slope of k, line k. I mean, yeah, if you just want to put slope here equals 2.1, then that's fine because it's the same. This is the slope of the perpendicular line is -1/2. That would be helpful. Still going, right? We're still passing through point P, which is at -3, -1. So Caden set it up this time for us to solve.
you have to put it in a
-1 equals.
Nope, because it's y equals mx plus b. So you put the y in. What's your slope? Oh, you said -1. Sorry, I thought you stopped there. So it's -1.
It's -1/2.
Okay, yes, sorry. You stopped after 1, I thought. So my bad.
Equal or not equals, but the parentheses.
Times.
-3 plus b.
All right, perfect. So we put in slope, x, and y. So -1 equals, what's -1/2 times -3? A positive, good, 3 over 2, plus b. So what do we do? Don't tell me b equals. These are being added. I need to subtract. No, I'm going to say I'm going to subtract 3/2. 2/3. No, we can combine these. What is -1 minus 3 over 2? So we need the same denominator, so this would be -2 over 2. What's -2 over 2 minus 3 over 2? Yeah. So negative 5 over 2 equals b.
So then you put it in the slope.
And we've got our slope and we've got our b. So we're ready to write our equation. So y equals, what, Caden?
-1/2 x plus -2.5, but that's just because I didn't mind the decimal.
Okay, plus, okay, you could say negative 2.5. Okay, or you could say y equals negative 1/2 x minus 2.5. You don't have to have the plus and negative. Or you could have y equals negative 1/2 x minus 5 over 2. Or you could have it plus a negative 5 over 2. Any of those, right? Any and all of these are correct and equivalent. Questions? Are you sure? Okay. All right, then the last one is just a little tidbit of information about horizontal and vertical lines to refresh your memory, hopefully. All right, so horizontal lines, we're going to see y equals b, or you might see y equals 2. Okay, that you're going to graph that as a horizontal line because every point on the line has the same y coordinate as the y-intercept, which is why we say y equals b. Okay, for a vertical line, we're going to have x equals k. So you might see x equals negative 4 because every point on the line has an identical x coordinate, which is your x-intercept or k. So again, that's just kind of a little reminder of when you see a line that, or it says graph the line, you're like, what? It's not a slope-intercept form. You know it's going to be horizontal or vertical. So anywhere that x is 3, so let me move this down a little bit. So if I look at this, anywhere that x is 3, okay, so x is 3 here, and x is 3 here, and x is 3 here. So anywhere x is 3, okay, it's a vertical line. Or y equals 2. Anywhere that my y value is 2, so like my y-intercept, anywhere along here is a y equals 2. So we get a horizontal line. Okay, so you can do your on your own. And then you can get started after I get them checked. You can get started on your homework. Woohoo! That's so much fun, Miss Talbert. Math is my favorite. I love it.